Assalamualaikum and hi everyone. So we continue introduction chapter part 4. So this is under them second order performance description. We have defined two parameters associated with the second order system, the damping ratio zeta and the natural frequency omega n. Other parameters associated with the underdamped response are rise time, peak time, percent overshoot and settling time. These specifications are defined in this figure. So this is the rise time, TER, the time required for the waveform to go from 0.1 of the final output until 0.9, until 0.9 of the final value. So this is the rise time. Second is peak time. Peak time is the time required to reach the first or maximum peak. So this is the maximum amplitude or maximum peak of the response, of the final response, and at this point is the peak time. The third one is percent overshoot, or we label as percent OS, the amount that the waveform overshoot. Overshoot of the steady state or final value at the peak time. So this is the amount of overshoot expressed as a percentage of the steady state value. The fourth one is settling time. TS, the time required for the transient damped oscillation to reach and stay within 2% of the steady state value, or we label as 0.98 of the final value. So at this point, this is the settling time. So this is the definition of the rise time. This is peak time with the formula of peak time, pi over omega d. This is the formula to determine the percent of overshoot based on the damping ratio zeta. And from percent overshoot, if you are given a percent overshoot value in the question, you can determine the damping ratio zeta. So these two formulas are related to each other. And this is the formula to determine the settling time, 4 over sigma d, where sigma d is equal to zeta, the damping ratio, multiplied with omega n, the natural frequency. So based on this example, you can determine the peak time, percent of overshoot, settling time. From the denominator and numerator, you need to determine first the natural frequency, and second, use this value to determine zeta. The next one, you can determine all of these parameters: peak time, percent of overshoot, and also settling time. This is underdamped second order response, the pole plot for a general underdamped second order response system. Is reproduced and expanded in this figure for focus, where omega d is the imaginary part of the pole, and it's called damped frequency of oscillation, and sigma d is the magnitude of the real part of the pole and is the exponential damping frequency. So sigma d is equal to zeta omega n, the damping ratio multiplied with natural frequency, where the damped frequency of oscillation, or omega d, is equal to omega n multiplied with Z 1 minus zeta squared. So in this example, you are given a plot, the pole plot. You need to find zeta, omega n, peak time, percent overshoot, and settling time. From this one, first you can find the zeta, which is equal to cos theta, or this is the formula, cos arctangent 7 divided by 3, the omega d divided by sigma d, and this is the zeta, 0.394. Once you find the zeta, you can determine omega n from this formula of sigma d, zeta multiplied with omega n, and in this case omega n is equal to 7.616 radian per second. The next one, you can find peak time, which is equal to 0.449 second. Percent of overshoot, you calculate it using the formula given, using the value of zeta, the damping ratio, which is 26%, and also the settling time, which is equal to 1.333 seconds. Okay, that's it for part 4. Thank you very much.